As in the 222 case, here's the 3-2 that we had done with an axial combination that was allowed by um, the our axial relationships through cosine A, cosine B, cosine C. And now we're going to add extenders to it. Just like the 222, we're going to go through all the cases and then show you that some of them don't produce unique features. Let's start with the horizontal plane. Now before I do that, I want to make you remember that we had used these kind of classic shapes to represent some of these. And remember, just to trigger your memory here, this was the one where we found that I could have twofold axis coming out of this face. Then I have a twofold axis coming out of this edge, right? So then there's another one coming out of this face and another one going out of that edge. So when I look down with my eye down this way, that's where we get our stereographic projection with no inversion center or anything like that. And what I'm doing is looking down there, and I would see one of these guys coming out. And of course that has to continue on the other side. But this one would normally be related to the one on the other side because I have threefold rotation, right? So, that one would eventually come over to here with 120 degrees. But of course that one passes through, also. And so here's like, for example, something coming out of the face, something coming out of the edge right here. And that's the angle. If I call that angle A, this would be angle A, right? And then I have, of course, another one here. So looking down, that's how I get this stereographic projection. Now if I were to draw the motif for this, and I'm going to draw these lines just to aid my direction again. These are the axes, the twofold axes. So if I use the twofold axes to help me draw like that, because I have my threefold axes, and that would be a that would represent that. And of course, when I look down one of these threefold axes, there's this guy on this side is being rotated around onto the other side 180 degrees with the twofold axis. So now it's a little bit easier to see if I add my horizontal mirror plane, right? Well, we know what happens there, right? I end up reflecting the ones green, which are on the back side, to the front, and vice versa. Okay, so I did that. Now you can see kind of what symmetries have formed. And what happens, as you can see here, I end up with mirror plane passing through there, mirror plane passing through there, and mirror plane passing through there. So we get some higher symmetries there. So, in a way, we have a threefold axis, right? And we have created these mirror planes everywhere. Now, just by putting in that horizontal one, we get the other ones. Now, upon closer inspection here, you notice also that we're related. Let's take this this red one. If I rotate this red one all the way over here and try to invert, it wouldn't work because I don't come on the other side. But notice how if I come over here 60 degrees, and then invert. So let's see, 60 degrees. That would be on this side actually. And then invert. I pop out, and actually it relates. So I've transformed this center here also into a, you could think about this as a roto-inversion um, for a pi over 3 axes, which is sometimes written as something like that. Okay, but for threefold axis, that's not true. We just showed you that this thing rotates through, and if I, rotates through to here, and if I do it, it's not. So for threefold, it is not. So there's kind of a double nomenclature here. I could call it, 3 over m, because actually, right, this is a true 3 plus a mirror plane here, a horizontal mirror plane, and so it's truly just a 3m, and I can see that it also has twofold axes, which I have to draw in here. And they have mirror planes. So this one could be called 3m2, or equivalently, if I thought about this guy, that's 6 bar essentially, right? Because it's a pi over 3 rotation. And I could write it as 6 bar m2 instead of 3 over m2. But either one is the same thing. The vertical plane, I think you can see pretty quickly that if we just look at our motif, that's the original motif. And now I place a vertical plane in here, as we did before. What we see is this gets over there. This guy, if I drawn this correctly, gets over there. This guy gets over there. And then you realize that it gives me the other mirror planes as well. And so this doesn't produce a unique thing. It produces same thing. Sorry, 3 over m. Nothing unique there. We can now do a diagonal here, which is very interesting, because with the symmetry, you'd think that that would possibly produce something. So let's look at that more carefully. So now if I were to put a diagonal plane through here, and of course the threefold symmetry would mean that they go through the other ones as well. Now you could see probably the simplest thing is to take this middle one. Again, it's kind of confusing since I have not drawn these things very well. And of course what these guys will do is start reflecting all these guys around, right? And so what we'll do is try to show you that here. And you end up with this kind of structure where, if you look carefully, you'll have two of the same elements in the back of the motif separated by this plane, and then they're separated in the front. See, back, front, back, front. So over on our diagram here, we have two-fold axes passing through here, but then in between those two-fold axes, we have these mirror planes. Now let's look a little bit more carefully at the relationship between some of these, see if we transformed our axes. Let's suppose I rotate this one 120 degrees, which would go by this first case, but then would make me hit this second case here. And now I go through inversion. And indeed, I end up where I'm supposed to. So there is a 120 degree roto-inversion axis here. That symbol will be this triangle with a little cyan circle in the middle of it. Our little threefold roto-inversion axis in the center. So with that, we would call this, it's got a 3-bar roto-inversion, 120 degree rotation plus inversion. And each one of these two-fold axes is perpendicular to a mirror plane. But they're all the same because they're all produced by the threefold axis. And this also tells you that there is going to be an inversion in the middle, because if I have a two-fold axis perpendicular to a mirror plane, it says it's going to have an inversion axis in the middle. So I have an inversion, but it's also a 120 degree rotoversion as well. Final case is adding the inversion, and the one we just saw already has the inversion center in it. And so if we do the reverse case, we're going to add inversion center in here, and then we'll see as we unfold it, we'll arrive at the same place. So it's not a new element, it's already in here. And so that's why in this diagram here, this table, we have this thing, which is the same as this guy above. So what we've just done is we've done this direction here. We did this one first by the horizontal. We showed that this one is nothing different. And then we showed that we get 3-bar over 2m by adding a diagonal mirror plane. Now we'll finish up with only doing the cases that produce new. I think you get the idea of how some of these produce either the same thing or something that, like in this case, is not valid. So in the next lecture, we'll start to only do those combinations that produce an end result.